Welcome to a new test and teardown video. This time it's another Hewlett-Packard. A Model 204C oscillator. So I believe this one is probably from 1968. It was manufactured, I think, about 10 years. So it could also be a lot newer, but I see those connectors here. So I think this one is an early model. I found some pictures and some information from HP Memory Project. And they say this model was first listed in 1968. I also found a lot of different schematics. Some also talk about the version C. So there's also a D version, and the difference between the C and the D version, that has something to do with the amplitude. So the D version got an attenuator here, and then the amplitude potmeter is in the middle. So that is, I think, the only difference between the C and the D. Yes, this one covers from 5 Hertz. C times 5, and that is 1, so that will be 5 Hertz. And then all the way to 1.2 megahertz. And as you can see, yeah, we have a little problem. The HP logo here is missing. We got a little bit of scratches here in the front, and there's something that bothers me a little bit, and that is the scale here. It's a little bit funny to see that we got those marks here, but if you use this knob like this and you got long nails, then you could scratch the varnish or the coating off, and that is exactly what I believe happened here. You could of course also do this with your fingers, but no, I mean with your skin, then it would look a lot different. So I think this has something to do with nails. That is a little bit weird. And then we got a nice geared knob here. So far, the only thing that I did, I took my inch Allen key and then I fixed the knobs. This one was way too far out, and the other two, they were just too far in. I prefer to have at least 1 millimeter of air between the knobs and the front. This way knobs move more freely and they don't tend to touch the painting of the front. So I think it's funny people don't do this right. I just bought this at a local flea market and I didn't pay much, so I don't expect too much. The only thing I found was one missing screw. The reason why the both missing is I just took the other one and used it for measurement, and of course I was able to find a new screw. We got a little bit of a screw challenge. As you can see, this one can be long, while the others here needs to be very, very short. And with American equipment, yes, those are of course all inch type screws. And there isn't a lot to say about the rear. This one is without all the battery options. This one comes in 3 or 4 different options, and it's all easy to see here on the back. And as you can see here, we don't have the battery options, so that's quite all right. There is a little switch here. So this is the low distortion mode. And if you click it over to low distortion mode, you need to change the frequency very, very slowly, because this adjusts how aggressive is the feedback system and that will of course change the distortion. And I'm super happy about the IEC connector. That's quite modern. So let's open this and inspect the capacitors and all this kind of stuff before I power it up. I really try to encourage people to do stuff like that with old equipment you buy secondhand. Open and inspect before you power it up. This can save you a lot of trouble in the repair and restore process later on. If you blow this up, it's really stupid. So better inspect first and then let's play a little bit later. So first, a little open and inspect didn't go too well. So there's another box inside the box. See, all the way around it is double cased or double shielded. There isn't a lot to see. Yes, okay, we got some adjustments, distortion, ADC, bias, high frequency calibration, and some frequency stuff here. But I think that is more or less all we can see. So, I wanted to look at some capacitors, but all I find is a tiny little transformer down there, but not a lot more. This is one of them IQ tests. I mean, I think I kind of failed it a little bit because I think there's a time limit. If you want to pass any of these IQ tests, you need to do it within some sort of a time limit. Not half an hour later, you can't come and say you're a clever guy. Sorry, but you need to take away both of the side panels as well. All right. So when this is done, both of them, obviously, right? Then the rear unit is attached here. There's a connector to the main board, and then this one slides out. And there's a little hint about that here, and then it sticks into this. This cover here is 1 unit. There's no way you can open this. I will show you this in a second, but let's first look a little bit on the power supply. So this is a, yes, all-in-one little plug-in module. It is a obviously a linear regulator. I think it is plus minus 13 volts. There's a, yes, the output from the transformer is a plus minus 25 volts, and it's stored in these 2 capacitors. And then it is the positive side is Zener regulated. There's a Zener diode somewhere. It's that will be the one. And then this one manufactures a nice regulated positive, and then the negative side is a voltage mirror. So it copies the positive voltage and uses that one as a reference to the negative. It's super easy if you look at the schematic I was able to find. And it's quite simple way to do this. This is definitely how you want to do that, by the way. And then the output goes to those 2 capacitors. I do see a little bit of nasty down here, but it's probably just solder. Somebody maybe changed these 2 capacitors. They don't look original. So let's try and look at the main unit. See, what I'm saying is this whole unit here is assembled like that. So there are no screws. You can't disassemble it like that, but everything is screwed to the front. So I think all you have to do is just carefully slide. See? I don't want to damage the variable capacitor. This is so delicate You don't want to hit it with your screwdriver or anything. I actually don't even want to touch it with my fingers, because I really hope this one works. See? A nice all-in-one shielded case. I'll hide this down here. And here we go. Beautiful. That is one big dual section variable. Wow. And here is probably the tuning capacitor for all the very low frequencies. And that is what I wanted to inspect, if that one is nice and clean, because I don't want any leakage to be around here. So I will now inspect all this carefully. We also got a few tantalum capacitors down here, that one, and then this and here. And yeah, I see a little bit of bad soldering, but not super bad. See, this circuit board here is a little bit loose. Okay, so this is kind of all there is to it. Okay, we also got the banana connectors here. There, they're actually connectors. So look at that. You could just pull out the board if you loosen the two screws, I guess, but there is no need to do that, because then you need to desolder the wires for your capacitor. But that is all there is to it. Is there a little lamp or something in here? Why are we having all this? Or is this for grounding purpose or something like that? I don't know. It looks a little bit weird. It's also going down here and touching all the gearboxes. That is probably because if you want to touch this, you don't want to create some sort of a coupling into something that could potentially affect the frequency. So you see the metal here is also connected to a piece of metal that goes down to ground to chassis. It's also good because for ESD protection, when you are charged, what you do is you go here and touch this scale or this knob, and obviously this spark is going to go somewhere, and they want this spark to go directly to chassis and not entering any kind of delicate electronics. So I've been cleaning and lubricating also the different bearings and everything that moves down here. So now it is moving quite nice and smooth again. And I believe that somebody did change some capacitors, and that left a little bit of cleaning to do. And maybe I should show the schematic so you can see how this is designed. There isn't really not a lot of components in this. I don't know if I can show the whole circuit like this, right? So on the schematic, we'll see a few field effect transistors. I believe the two field effect transistors that has something to do with the main oscillator part. That is, of course, for very high impedance, and that is definitely needed to make this run at 5 Hertz. And you'll see the first field effect transistor is down here, and the connection to the circuit board is done using a Teflon plug-in, and that is because the leakage in normal glass fiber board is just very different from Teflon. So that's why they want to do that. You can also see the two first sections of the frequency setting switch. That's nylon, and nylon is also a lot better compared to glass fiber board down here. And a glass fiber board is, of course, again a lot better over this normal Pertinax or this paper-filled a material that you normally see in those switches. But I think that will be, yeah. So that is one of the filter effect transistor, and the other one is, I can't really say, but I think it is the first one down there. And then the rest is just a few NPN and PNP transistors. And that is really all there is to say about it. In the schematic, they really made it nice and clear, the whole capacitor section, and those two components you see here is inside a completely closed, shielded room. So I think I'll try and power this up so we can see if it is working. So yeah, let's just try and power this up, and let's try and remember how the circuit was for the power supply. So what I expect is the power supply will of course be on all the time, and then this switch will turn on the oscillator. So I believe that we will see a little bit of current consumption, 0.6 watts. So that is just the transformer is now energized, and we can of course turn it on, and then we got output. And what we see here is a lot of ripple, and that is of course because it's open. But what I wanted to see if it's just working, this is 1 kilohertz. Let's try and see if that is right. Oh, see. So this is it should be 1 kilohertz right here, right? And here we go. Oh, look at that. It is 1.005. Oh, I didn't expect it to be that accurate. Are you kidding me? How is that possible? And it's even open. I really did not expect that. So let's go for 4. This is as accurate as I dare to put it. And it says 4.28. And then let's go and give it 10. Okay, 11.58. Wow, nice. And okay, that potentiometer needs the classic clean. But other than that, I think I am ready to assemble it, and then I will perform some more measurements. One more thing to mention. So now it's on, and the power consumption is 0.9 watts. And let's turn it off, and then power consumption is 0.6 watts. So why do you bother turning it off? Because it is actually on while it's off. There's definitely voltage on the entire power supply and all that, right? Did I mention I was a little bit sad and sorry about the missing logo? I just called a few of my regular sponsor friends. I got a lot of these nice friends that always give me access to nice equipment. They sell me stuff, they give me stuff, they trade my stuff, and they always help me so much. And thank you guys a million times. And then look what happened. I got a blown up instrument. My friend was so happy to save this for me. Look at that. I think I'll be able to pull this off and put it here. And it is somehow it is glued or press fit or something like that. It looks a little bit like it's glued or something. And when I look at this hole, I also see some kind of glue stuff here. So I think I'll try and see if I can fix that. So here's what I think they do. They push in this logo, and they add some glue from the behind, and then they think that some of this glue goes down and glue this all the way around, but that don't really work. all I had to do was to push a little bit and then it fell out. So that is why people are losing these logos. So I used some 10-second glue and I put it all the way under this logo and also in the hole so that everything now goes all the way together. I don't think this is gonna fall out any day soon. That is so great. I'm super happy now. I've been trying to measure distortion. So this is about 1 kilohertz. And I don't know if you can see the meter here. The fun thing is the switch on the back that changes between the high and the low filter constants. I guess that's a dumb switch. Okay, here it is. See? There isn't really anything going on with that one. See? It's just barely detectable, right? Well, one thing that is definitely detectable, that is the level, the output level here. So if I move this, see, a little bit up or down, at some points it can get quite bad. Look at that. So what is going on? So it is that potentiometer that is causing some sort of distortion. If I move it 0 point something. So that's quite interesting. There's a lot to get from the potentiometer here. See, now it's good. This is how it should be when the potentiometer is good. So yeah, that is a little bit weird. So that was all I wanted to show you. So thank you very much for watching. Hope to see you soon again. Bye bye. Not that easy. Here you go.